We're going to start with chapter 9, section 4. We're going to graph sines and cosine functions. So we got to explore characteristics of sine and cosine functions. In this lesson, we will learn how to graph sine and cosine functions. The graphs of sine and cosine functions are related to the graphs of the parent functions y equals sine x and y equals cosine x, which are shown below. They just give us the table and then each graph. Just as an idea, just so you guys know, all of them look like this. It's just where you started. The sine starts at the origin and goes like this. And the cosine starts up here. And again, it just goes like this. So it's the same graph, just shifted a little bit. Obviously, the things may change, like the minimum and maximum value, the range, and the amplitude. But it's always going to be the same shape. It's just different on how you start it. Now, the range is from the top of the graph to the bottom. So this is the range. The amplitude is from the 0 to the top or from the 0 to the bottom. So the amplitude is usually half of the range. The minimum value is the peak of the bottom. So these two are minimums. And these two are maximums. They're the peaks of the up part of the graph. So those are the parts of these graphs. Now, the period is from where the curve starts to where the curve ends. So if we have a graph, it's going to do one full oscillation. So the period, which is one full oscillation, is going to be from here to here. Notice that if I were to restart, I would just put the same shape next to it again, like this. So that's 2 periods, 3 periods, 4 periods. Now, usually the period is based on 2 pi, which is again a full circle. So it's when we restart the graph. Now, if you notice, in both of the graphs, we have pi over 2, pi, and 3 pi over 2, and 2 pi. If you look at the unit circle, pi over 2 is right here, pi is right here, 3 pi over 2 is right here, and 2 pi is over here. So the periods are based on the axis of the unit circle. So we have the core concept. So characteristics of y equals sine x and y equals cosine x. The domain of each function is always all real numbers. Again, as you guys see, we have arrows for both of them. So it's going to keep going on forever and ever. So that's why the domain is always all real numbers. The range of each function, again, for the parent function, it's always going to be from -1 to y on the y, because that's also going to be, we're going to have an amplitude of 1. So we're going to go up from the axis 1 and down from the axis 1. So again, doubled is going to add up to amplitude of 1, because it's half up and then half down. Sorry, not an amplitude, a range of -1 to 1. The amplitude of the graph of each function is half of the difference of the maximum value and the minimum value. So for the parent graph, it's just going to be from the origin to the first peak up or the first peak down. But since sometimes they're not going to be the parent graph, so they're going to be shifted up, down, left, or right, you're always going to do the difference. So if we know our range is from 1 to -1, it's going to be half of that. It's going to become 2, so half times 2, 2 over 2, and that's going to equal 1. Again, sometimes as it's shifted up and down, it's good to always know how to do it. Sometimes, if you have the graph, you'll be able to just tell, but it's just good to know how to do it. So each function is periodic, which means that its graph has a repeating pattern. The shortest repeat portion of the graph is called a cycle. The horizontal length of each cycle is called a period, and each graph shown above has a period of 2 pi. So again, the periods may change, but for the parent function, it's always going to be the axis. So we're going to have pi over 2, pi, 2 pi, 3 pi over 2, and 2 pi. I almost skipped 3 pi over 2. That just means that at every time we hit pi over 2, we're going to have a peak. Every time we hit 3 pi over 2, it's going to have a decline. Every single time, notice pi over 2 peak, 3 pi over 2 decline. This is for the sine. For the cosine, it's going to be shifted to the left 1 period. So we're going to peak at 0, so right here. And we're going to have the lower peak at pi, which is in the x-axis. Again, if you guys notice, sine is always based on the y. Cosine is always based on the x. So it makes sense that the y is peaking at pi over 2 and decreasing at 3 pi over 2, as well as the cosine peaking at 0 or 360 and decreasing at 0 because it's a cosine. Now the x-intercept for the y equals sine x occurs when x is equal to 0. We're going to have at pi, up 2 pi, at 3 pi, and so on. Because for the sine graph, we're always crossing the x-axis at the x-axis of that graph. So if sine is y, we cross at the x. And for the cosine, it's based on the x, we cross on the y. So our x-axis are going to occur at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. It's always plus pi over 2. So not plus or minus 9 pi over 2, 11 pi over 2, 13 pi over 2, just on and on and on and on and on. Okay, so just like you guys probably may or may not remember about algebra 1, if we were to add anything in front of the sine or cosine multiplied, in this case is written as a, we're going to have a vertical shrink or a vertical stretch. And then if we add it towards the x, it's going to be a horizontal stretch or a horizontal shrink by a factor of either b or 1 over b. So the amplitudes and periods can change. The amplitudes and periods of the graph of y equals a sine bx and y equals a cosine bx, where a and b are non-zero real numbers, are as follows. The amplitude is always going to be that number in front of the sine or cosine. If there's nothing written, it's going to be 1. But it's always the absolute value. So always absolute value. And the period is going to be 2 pi over whatever that b is for the in front of the x. For a parent function, it's always going to be 1. So it's going to be periods of 2 pi, so a full circle. May not always be a full circle, and maybe sometimes a half circle. It oscillates faster or slower. If you guys ever seen sound waves, they're usually like this, and then when they get faster, they get like this. If you've taken physics, you probably have seen them. It's the same idea. Right here, we have a parent function, and here we have that it's oscillating faster, so it's no longer at the same rate. Just kind of for visual purposes. I don't think we're going to touch on that. We shouldn't. But just so you guys kind of understand how it's going to look. It's going to look either faster in the period of time or slower depending on the b. Also notice the b is also an absolute value. So even if you get a negative b or a negative a, always put them into a absolute value. All that's going to do is going to tell you the amplitude and the periods, so how fast or slow it would oscillate, a full rotation. Now, of course, if you put a negative, it's going to invert the graph in front of the A, and then if you put a negative, it's going to shift the graph on the B, just like you do in algebra. It's shifted based on where you put the negative. So, graphing the sine function, identify the amplitude and period of g of x is equal to 4 sine x, and the graph of the function, and describe the graph of g as a transformation of the graph of f of x equals sine of x. So I'm just going to graph the positive side to make it easier, but it's going to be the exact same on the negative. Actually, I'll add like one rotation on the left to kind of make it better, I guess. So the amplitude of the new graph is going to be the absolute value of 4. So it's just going to be 4. Again, that's R8 right here. And the period is going to be 2 pi over 1. So it's just 2 pi. So it's just going to be a full circle. So we're going to have pi over 2, pi, 3 pi over 2, 2 pi, and I'm just going to leave it there. And then on the left, we're going to have negative pi over 2, negative pi, negative 3 pi over 2, and I'm just going to add negative 2 pi just to have a full oscillating for all of it. Now, it's going to be 1, 2, 3, 4, 1, 2, 3, 4. For the original, we have an amplitude of 1, so it's just going to go up to 1. So I'm going to do the original in black. Being sine, we're going to start right here. We're going to go up to the center, back down, through the center, to the circle, and then back up. Always peaking at 1 or stopping at 1. If we go to the left, again, it's going to be the exact same at 1. Now, for the new one, I'm going to do in red. We're going to start again at 0, but we're going to go all the way to 4. We're going to go back down to 0, back down to 4, to 0, to 4. I'm just going to leave it there. I'll add an arrow. And then for the other one, we're going to go down to 4, to 0, up to 4 again, and then down. Again, I'll add an arrow. I'm going to add an arrow to the black one too. I forgot to do that. But that's how you would graph both of them. Now, if you're graphing both, at least on the iPad, you can change colors. If you're doing it on paper and they're asking you to graph both, make the parent function, just to keep it constant, a dotted line like this, and the new one, a solid line. That's just going to make it easier to tell, at least if we all do it the same way. For me, when you're doing a parent, and for you, when you're doing the new line. Now, if you don't do that, that's fine. Just let me know which line is which. So let's graph the cosine function. So identify the amplitude and period, and then graph the function and describe the graph of g as a transformation of graph of f of x equals cosine x. So our amplitude is now a half. Our period is 2 pi over 2 pi, so our period is just 1. The parent, I'm going to do the parent function on its own. Just because we have a period of 1, which is different because it's not in a pi form. But the original for cosine is going to start up here. Going to go through 0, down to 1, up to 0, back up here. And again, this is negative pi over 2, so we're going to go down to here. That is negative pi. That's going to be the cosine. Now, the period being 2 pi over 2 pi, it's honestly just 1. Since this is in radians, and 1 is just a number, I'm just going to, for now, graph it in the same place, but I'm going to do it in red, and I'm just going to use the same one just to notice. This is the half because it's the amplitude, so we're going to start up here. 0, half, 0, half, 0, half, 0. Sorry, the left side looks bad. 0, there you go. So for they want us to identify the amplitude and period. I'm going to do the amplitude and period for all of them first, and then I'll just graph them in the same area. Hopefully they have the same period. If not, we'll make graphs for each one. So the amplitude for this first one is a fourth. The period is 2 pi over 1, so just 2 pi. The amplitude for this one is 1. The period is 2 pi over 2, so just pi. This third one, the amplitude is 2. This period is 2 pi over pi, so it's just 2. The amplitude here is a third. The period is 2 pi over a half, so that's going to be 2 pi divided by a half, so keep change flip, so it's going to be 4 pi. I think I should be able to graph most of them in the same one, except for number 3. So I'll graph 1, 3, and 4 in the same one. So this is pi over 2. This is pi. 3 pi over 2. 2 pi. I'm just going to do 1, 2, 3, 4 pi. I left those 3 blank. It's just pi over 2 plus 2 pi. Pi over 3, pi plus pi over 2 is 3 pi, and 3 pi over 2 plus 2 pi. It's just going to give us another number. Right now, I just want to get the graph width, and then we'll go ahead and do the other ones. Now, I'm going to do this first one in black, the second one in red, the fourth one in blue, and then we'll do the third one later because it's on a different domain. So we're going to start with, I'm just going to do an amplitude of 2, 1, -1, -2. So it's saying it's an amplitude of a fourth, and it's a sine. So we're going to start right here. Our fourth is not very tall, so it's just going to go up to a little bit, down to a little bit. And then that is our period because we start the drawing again at 2 pi. If we were to keep going, it'll be like this. Again, so every 2 pi's right here, we restart the drawing. Now, for the next one, it's a cosine. And they're telling us the period is of pi. So it has to do a full rotation before we get to, what's this thing called? Before we, as soon as we hit pi, we need to be restarting the graph. So this is going to be a very fast oscillating graph. It's an amplitude of 1, so I'm going to start up here. We're going to go down, peak, up, peak. See how instead of being so spread out, it's a lot smaller. And again, right at pi, we restart the drawing. And down, peak, up, peak. Again, right at 2 pi, now that's 2 oscillations. We restart. Again, down, peak to peak. We restart. And we restart again. So every time we hit pi, that begins again. Now for number 4, we're going to have an amplitude of a third. So it's going to be about up here. And it's cosine. So every 4 pi is a full rotation. This is just going to start here and end right here. So it's going to be up. It's going to hit 0 about pi. Going to go down here. Going to hit 0 around 3 pi. And it's going to go there. So these 3... these are the oscillations to the best of my abilities. Hopefully, they're making a bit of sense. I'm trying to draw them as evenly as possible. Now, I am not perfect at drawing oscillating graphs, but that's how it works. And then for number 3, which is a tone thing, it's saying it's at 2. So if I go a half, 1, 1.5, and then 2. We have an amplitude of 2, so this is 2. This is -2. It's sine, so we're going to start here. We go up, down, and then back up. So that's how 3 would look. We just, instead of using pi, we're using a different x-axis, but it's still the same oscillating process.